So, hello. My name is Grzegorz Wojciechowski, and I will be presenting to you today the White Rabbit, finding your own way of creating games. I also like to call it how I created my ideal resource system. And when I started to applying for this presentation, one of the reviewer asked me a pretty interesting question. Why audience want to hear that from me? And I'm not somebody you really know. I didn't do a lot of stuff, but I work for 4 different big companies for more than 10 years. I started in Techland in Wrocław, worked in Ubisoft Montreal, Sumo Digital in Sheffield, and currently I'm still working for Unity. And normally I'm presenting some Unity topics, but this time I decided to do something different because other than that, for more than 21 years, I do my own project. And I'm creating it under the Coffee Monsters, which is just the name that I'm using. There is no company, no organization, just me and one of my friends helping. And like everyone, I started to doing my own stuff because I wanted to create the games. And over these 21 years, I created a few of them. And the newest one, it was my attempt to recreate the Little Big Adventure, which is one of the old game from the French creator. Last month, there was announcement that they starting to doing the professional full remake of it. So I kind of wrapping up the project. We'll try to finish the first level and move on. And this is the result. This is the project of work of 11 years, one person doing animation, art, code, tools, everything. As you can see, I don't try to hide anything. The issues are also visible on the video, and there is more than one. And to build any kind of the game, we need tools. These days, we can use Unity, Unreal, CryEngine, Godot, or anything what you want. You can also go more hard way and create your own. And to create your own tool, when you're starting to creating your own engine, generally, you also need tools. So in the old good days, before Unity and Unreal, because this is when I started working on the project. When I started, none of them were available, and I kind of decided to build everything from the scratch. If this was a smart decision or not, well, we can discuss this next to like drinking beer. I'm partially happy about it, partially not. But what is meaning? You need to create the tools to create the game. And I started to doing this. As you see, this is editor that I'm using for it. But this is just one of them. There is a lot more tools than just the editor. There is the system for managing the resources, for the testing, for the creating of the state machine, visual scripting. There are scripts for the compilation, building of the project, for everything. And I don't want to talk about everything. What I want to talk about is just a small portion of it. And this will be the resource system. So simple problem of managing the assets or resource, however you want to call them. And everybody knows this problem. We loading resources, using resources, and getting rid of them. And how many of you, after using whatever technology you are using right now, thinking that are able to create better resource management than is there? So if you could raise the hand. Well, I know this guy, he's creating his own technology, so yeah. So this simple problem have very often complex solution. And the question is always if it's really necessary. Because we're saying it's too slow, there is some problems, this don't work, that don't work. And when we think about the loading of the resources, very often we start to thinking about this simple graph, where we have request, checking if something is the cache. If we found something in the cache, we just don't want to load it. If it's not, we're loading the source, converting into the format that we can use by the engine, and adding to the cache to not load it again. Simple thing. But when we start to implementing it, it's becoming a lot more complex. Turning out that this is not loading of the resources, it's loading of different resources, and creating different data for each of them. One step further, turning out that we need to support different formats. We need to support FBX, object, different textures, because, for example, we're getting resources in the raw data in this format. Step further, we start to discovering that it's not only about one resource, but all dependencies of the resource. And even just this problem, resolving the dependencies, is a big problem on its own. But this is not ending it. Another step is to starting pre-caching the resources, what most of the engine doing. And what they're doing, they checking the cache, resolving the problem if resource changed. They deciding to rebuild it, storing it, convert the asset to the final format, and storing it on the hard drive. Thanks to that, the next time we try to open the resource, it's already there. And this is, for example, the building process in Unity. When you're starting the project, what it's doing is creating this asset for further use. And finally, we have unloading of resources, which is also relatively simple. We just checking if resource is no longer used, and if it's no longer used, we're removing it and just destroying the data to make space for other things. So our simple problem of loading, using, and getting rid of the resources turning out to be really complex in the fact. Because loading taking times, we need to manage dependencies, we need to handle errors, because nobody likes when like the editor or engine failing because we done something wrong with the resources. If somebody give us invalid mesh, we still don't want to crash the whole thing. Using is another really complex problem because we passing like here, mesh to drawing, but what's happening there, we really not necessarily using it at this moment. We can add it to the queue, which will be executed later, and drawing will happen in further time. So we need to preserve the resource as long as we're using it. We need to consider lifetime of resources. And this is really important with the graphics API like Vulkan, where what's happening, we can submit something to the GPU for drawing, and we think that we finish with the texture, for example. We can destroy it. But in reality, this is not the case. What's happening then, we just pass the information for the GPU that the GPU should use this texture for rendering. And if we get rid of the texture at this point of the time, what we start to doing, we're destroying texture that will be at a given moment render, or it's already rendering. And you're getting then the device removed. You need to also consider a state of the resources. Because what you may want, you may not want to load resource right away. Because we have, for example, scheduling loading of hundreds of meshes, and we start to use them after the loading. So we don't want to spend the time waiting for them. And want to only be careful about it, we want to protect from it when we start using it. And finally, the destroying of the resources is another pretty complex problem, where is the question if you really want to destroy something. Because if we want to have the levels which are using the same meshes, is not a problem. We can load the mesh once and use it across multiple maps. But what if the next map using completely different set of the resources? At this moment, we would want to get rid of the resources when the level is unloaded. So there are different strategies, very often tightly connected to the games. And at this moment, I want to welcome you to the engine and the architecture that that developed over the lifetime of the project. There will be a lot of graphs at the beginning. Later, there will be also source code, where I'll be discussing how to create the completely new resource in the system. But first, about my little project, how I like to call it. So this is the attempt of remaking Little Big Adventure. It's only 11 years on development. It's personal project, so I'm not working on it full time. I'm working after hours. It's desktop only, so PC. Windows, I had the port for the Linux, but decided that it's taking too much time and effort to support it. So for now, I put it on the shelf and focusing only on Windows. It's deferred rendering using PBR, which I'm implementing on my own. Multi-threaded design, which adding a lot of problems. I have full authoring tools, which are including editors and all the tools that you've seen. It's written in C++, OpenGL, using Fmode and Qt for the UI of the tooling. Another thing is that it's really small team. Right now, on the project I work and my friend, which leading to the conclusion that things should be simple. So when I work, I don't spend a lot of time on doing stuff, and I like to optimize stuff because I don't like to do the boring stuff after work. Content created is using Blender, where I have my own exporter, Substance Painter, Marvelous Design, and a few other programs, which supporting different formats give me different results, which I need to unify to use into the engine. I'm using also external asset libraries, and this is the asset that I may use. And I have right now of them like few gigs of the texture, which are in different formats. So they are not the formats that I supported initially. I needed to extend the importer just for them. There is also a problem of that they are a lot bigger than the one I designed myself, and there is problem of licensing. So this is why also resource system was so important for me, because it's not only about the creating the packed format which nobody can read, but it's also sometimes license of the assets that we're using that forcing that. In this case, I can distribute the texture inside the resources, which nobody can open, but I cannot put the texture into the project, which everybody can open. Because at this moment, I can be sued because I'm distributing texture that are owned by somebody else. And there is also a problem of the external libraries, which is, in the others, is the point of the libraries like opening the FBX. It's cool that we are given the exporter from Adobe, but the problem is you cannot include it inside your project. You need to use open source replacement, or you need to download it force user to download it from the web page. So in case of the game, I don't want to include it inside the game, but I want to have it inside the tooling. So when I'm releasing final game, I don't need to worry about it. And there is, of course, problem of the performance and stability. Because what's happening over the lifetime of the project, when I started, it was really small projects. 860 files of the data and 165 megs. But 3 years later, already the size increased 5 times. This was the moment when I decided to redo the art into more modern one. And right now, I'm on the level of 16 gigs and 12,000 files. And this is still small project. Like big project right now, which some of you work on, have like 250 gigs or 500 gigs of just data. And this is crazy amount of the data to process. We don't use it in the final game, but we want to have this comfort of going into the editor and being able to add anything. And to achieve that, I created my own architecture. When I started, it was very simple. There was game and editor using the same DLL. So in the game DLL, there was editor and there was game. This is where most of the people creating their own engine starting. It's a very simple thing, and it's worked relatively well for a moment. Sadly, for me, it became really messy. So what happened? The editor bits started to polluting the game code, which we see all the time, where, oh, I want just to update this one variable somewhere in the game, and when I'm running the editor, because it will make things simpler. I didn't like that, because it added me so much effort when I changed something in the editor, started the game, and it's just failing. Because I modified something in the game, which I shouldn't, so I fixing the game, restarting it, and making it work, and so on and so on. So I decided that I want this really clean design, where I have the editor backend, which what it's doing is only receiving the events from the editor. So events would be load the map, move the object, select the object, really simple commands, which are executed on the level of the backend, which contain all the editor bits. But as you can see on the graph here, there is a small problem. There are right now 2 file systems, which UI and the backend have their own file system, which you can open. And editor is, in this case, completely separate application. So to resolve this problem, I thought a lot how to do it. I consider using the same TCP/IP connection between the front end of the editor and backend, just to make it work. But this wasn't clean enough for me, especially that I also want to support hot reloading in the game. So I added something called file system server, which works like the FTP server. And what it's doing, it's serving through the TCP/IP files to the editor and the game. The big advantage of that is that right now, everything is in the full sync. Turn out that this was the great decision, which also in the future I want to lead into design like the Google doing right now with the Google Drives, where you can just go into my computer on the Windows, open the drive, and you have all the files for your project, which you can modify, save, where underneath there is completely different way of managing them. This would help a lot with the problem like moving files, copying files, renaming files, which is still a big problem for us, how to preserve all the references where artists want to do that. And very often they don't want to do it in the editor, they want just to do it in the most convenient way. And this would allow to achieve that. But what happened here is that file server bring me to the conclusion that what is really building of the resources is tooling, and the game really need to know about building of the resources. And turn out that really not. What we want just to open the resource. So I started to shifting the design into a situation where when file system get request to opening the resources, I just triggering building of the resources, and it just build it. And when it's finished, it's returning the content of the file to the application that using it. Thanks to that, game no longer know about compilation of the resources, it's only know that it's opening the resources. But as you can see here in the graph, there is still resource compiler inside the engine. And this is because there are some dependencies which are problematic to remove. And this is happening all the time for all kinds of the engines, where we want some bits and pieces from the game to build the resource. For example, I want the components to be part of the objects. And when I'm compiling the objects as the resource, I want all this information to be there. And it turned out it's not so easy to get rid of that. And it took me a while to do that, when you will see that. Another step of this evolution of the whole system turned out that the resource compiler before had multiple threads. So different threads compile different resources, which was a problem, because if one of them crash, it's killing the whole resource compilation pipeline, which we don't want, and it's creating a lot of problems. Multi-threading is really pain in this. And we cannot do anything about it. It's just complex, it's adding a lot of issues with the synchronization, accessing different kind of the data, even accessing the file system. So what I done, I decided to go into the simplest way, where I created resource builders, which is just another processes, which what they're doing, they only compile some set of the resources. They are single-threaded, and how they work, they're getting the request from the resource server, and when they're receiving it, they're opening one compiler, compile the resource, returning the result, and waiting for another task. Which is great, because if they fail, one of them, it will kill itself, and you can just reopen it to recover the balance. And also, another thing, you can balance it. So if there is more work, you can spawn more of them. When there is no work, you can just kill some of them to recover the system resources. This was still not the end. I was still not happy because it's very hard to add in such a case something new to the engine, which, as one of the point of me, it was simplicity of adding that. So what I decided that every builder should be its own DLL. And how it works, I'm writing just simple compiler for one specific type of the resource, which land inside this one DLL. And thanks to that, I drop in this DLL to one folder, and right away all the builders know about it. If I want to distribute it, I can just give somebody the DLL, and he put it in the folder, and it's compiling everything again, which making it easy to expand the possible resources that are there. And the final step was removing of the resource compiler from the engine, which was kind of great. It took a while to do that. But what is the greatest about it is that the game right now don't know what is the compilation of the resource. Editor don't know what is the compilation of the resource. They know how to create the source data for the resource, but they don't know what compile is. They just know how to open the file. Which simplifying the final build of the game to just removing the editor bits, and you have the final game, which you can ship, and it kind of works. And all of these steps lead to some rules and limitation of the resources. And the first one is resource has only one instance. What is meaning? That in the lifetime of the application, you cannot have multiple instances of the same resource. This is to save the space and the resources. It's pretty trivial. Resources are constant, so you never can change the resource when you loaded it. What is meaning? A lot of engines doing these tricks where you edit something, they're changing the resource data to have fast update of what you've done. I'm avoiding that because it's creating a lot of problems later. And in my case, I'm supporting hot reloading, and the whole technology is based on it. It's great for the game because for example, deciding that I'm changing the model, I just dropping the new version of the model, and game editor or multiple game instances automatically reloading the models, and I can continue just testing without reloading application or doing anything special. Another thing, resource data can be replaced. So in meantime of the running of the application, data can be changed because of the hot reloading. This is something that you want. It's annoying when you see small issue or graphical issue, and you cannot just fix the shader without closing the game. And resource compile without knowledge about the game. And this is the encapsulation that I mentioned before. It's so you can build the DLL for the full compilation, and you don't need anything for the game there. And with that, we'll move to a little bit of the code. Please don't be scared. There is is a lot of code there, but only small pieces we'll be focusing on. And the first one is the compiler of the resource, in this case, state machine. To show you how simple it is, you need to override 3 functions and create a project for it. In the first function, you using the over here, you're defining just simple header information where you're defining the major version. So when you're changing the format, or minor version, when you screw up and just want to recompile the resources, it's helped a lot. And the second one is the system that will compile it inside the game. And the last one is the extension that the compiler will support. Step 2 will be adding the sources, which initially I had opening of any of the file, but turned out that manual operation on it make it a lot more sense. You have more control, and there are sometimes resources which you want as the dependencies, but you don't want to open them. And finally, you're creating the data, where you're creating just the blob of the data. So over here, the last one box is just you writing to the virtual file, which what it's doing is writing to the memory. The last step is creating estimation of the memory. I'm using this to balancing the caching of the resources. So I have the pool of the memory I spent on the resources, and I hold resources in memory as long as I can. And this is so when I unload the level and load another level with the same resources, they are already there. And turning out that the loading of the level is very fast. But if I'm loading level with different resources, when the new resource don't have enough space for to be created, I just releasing old resources and putting in their place the new one, and so on and so on. This is pretty cool when you have you want your game to use specific amount of the memory, which is important for the console, for example. Another step of defining your resources is creating the resource itself. And this is the thing that I mentioned about the separation of the data and the resource itself. So the first one, you're defining the data, which the resource has, and this one can be reloaded. Another one is the container, which will always be in the memory, only memory backing it will be changing. And the final one is another one is the resource creator, which is responsible for loading of the resources. So far we had compilation, resource data, and resource creator. Where first we're creating the container, and this is because when you're requesting the loads, I'm creating just temporary container and returning for you the container. This giving you the possibility of trying to storing the data without really accessing it or even waiting for it to load. So it's fully loading asynchronously in the background. Then I'm reading the data from the blob and just filling up the data that I had. And finally, I'm releasing the memory because allowing to do crazy stuff with memory, like loading stuff in place. And here, I just am sure that I'm cleaning it however I want. And finally is the usage of the resources, which there is not a lot of complex stuff, which is just finding the entry in the file system and creating the resource. The only interesting thing about using it is that using resources require locking. And this is what happened there is just that I want to be secure that when hot reload stuff happening is not in the middle of doing something. It would be really bad if I reload the header of the mesh, which magically changing, for example, from thousands of the objects to just 30, which happened for me. There was a lot of crashes with that, and they are very hard to trace. So I decided to add the locking. The cool thing about it is that in final build, the locking is just returning the pointer because there is no hot reloading in the final build. So for the final build, there is no overhead of the system at all. And a little bit of the stories, the interesting part, what went wrong. The first one is interesting one because I also discuss a very similar thing with the friends from the work, is using the jobs for loading of the resources and why it's hard to do that. And the idea is simple. So we have two job workers, where we're scheduling on the first worker loading of the resources, and after that we try to access the data. So we need to wait for it to load. And because I want to use the workers for loading, there is another job which is scheduled in the job system, which loading it, and because we're waiting on this thread for the job, another one will load in the background. But then what's happening? There is a lot of tasks which was submitted. So we end in the situation where we can really kill the performance of the job system just because we didn't organize things correctly. So we have a lot of other jobs and loading of the resources happening somewhere in the background. And I came with two solutions for that. The first one was active waiting. So what is happening? When I entering the log for the waiting of the resources, I can load other resources. This is kind of trivial and helping with that I never had jobs which only spinning and just waiting for the resources. The issue with it is that if I don't accessing the data right away, because of the async way how things works, I'm kind of in a situation like that. We are scheduling the loading, but the loading of the resources will be delayed very far into the time because I'm doing other stuff. I don't know, preparing the map, building the navigation mesh, things like that. So I come with the second solution for that. It's just creating special worker for that. This helps, as we can see, because now I'm scheduling resource A and then loading in the parallel the resource. We're still kind of waiting on the thread. But it's also failing when there is a lot of requests. And this may not look very common, but when you're loading the level, happening all the time. Been there, done that, and it's kind of not good. So what I'm using right now is the combined solution, where I just loading the resources on the when I'm locking, and also loading them in the background thread. Probably this is not the ideal solution for some of the games, but for me, it's working. And even if there is slight overhead of doing that, it still kind of works pretty well. The another thing about it is the multi-threaded that I mentioned. And the case like that, where not everything is optimal, is pretty common in the multi-threading. In this case, when you ever requesting the resources to load, I sometimes preparing the resources multiple times. And by preparing, I mean reading of the dependencies, reading of the kind of the source files I need to read and rebuild them. All of that is requested multiple times because it's turning out doing more is still cheaper than doing one of those things at a time. Because it's not happening very often, and turn out if I block the whole system with the locking, it just was killing the performance. So the final thing that I want to say is the ideal solution that I come with. And it's that. There is no ideal solution. Every system that is written for your specific situation. So if you have small team that don't have time building really grand resource system, just don't do that. It's probably not worth it if you don't want to invest time in that. Or maybe you want to do that, but you don't have people for that. So use system that works for you. Create something simple that works and allow it to evolve over the time. What you see here is not something that happened in half a year. This is continuous evolution of coming ID from the operating systems, from the FTP, ID like trying to resolve the problem for the artist. Everything is coming with the time. And the same with the solution for the Unity, where we are hearing a lot of people saying that, why you don't do that? The problem is, when you start working on Unity, there is some way of working which we need to preserve when we're updating the stuff. And it's not easy to preserve workflow for thousands of users. And that's why there is no ideal solution for the things like that. Just try to find your own way, try to find your own solution, and just make it work for you. And with that, we'll move to the questions. Are there any questions? Anyone? Okay. So if there, yeah?
No question, just wanted to say great music for Make Adventure.
Yeah, it's created by the Katia Savia. She's a friend, she's like also the YouTuber. And she created like the recreation on the piano for that. Yeah. I don't see any more hands up, so I think we are done. Thank you very much, and have a great day.